So we've just shown that the vector A cross B is perpendicular to B. If we let capital A stand for this first vector, capital B stand for this second vector. And since these could stand for any two vectors, A and B, this is generally going to be true. We've proven it. And we could write out all the mess, same thing for the vector A, and we'd obtain the same result. The cross product is 0, meaning that the cosine of theta is 0, meaning that theta is 90 degrees, or that the two vectors that we've crossed, in this case A cross B and B, are perpendicular. Okay, so we've established that A cross B is perpendicular to B. We've proven that. And we could just as easily prove that A cross B is perpendicular to A, just using the A vector the way we did the B vector. The direction of the cross product is determined by the right-hand rule. The right-hand rule, well, let's consider that if you have two vectors, unless they're parallel, they define a plane. Okay, so you have the vector A, the vector B. Imagine that we just have the J vector and the K vector. Okay, they define a plane. That would be the YZ plane. And there's certainly a direction perpendicular. That would be this direction. This plane is cut at a perpendicular by a line that goes in this direction, but also by a line that goes in the opposite direction. Okay, and the vector, remember that we said that J cross K is in this direction. Okay, could have been in this direction, but the way the right hand works, it's in this direction. You have two perpendicular directions and you have to choose one. So unless they're parallel, any vectors A and B will define a plane, and the line through the plane could be in either of two directions, and the right hand rule selects the correct direction. Another thing that would be fairly easy but extremely messy to prove is that the magnitude of the cross product is equal to the magnitude of A multiplied by the magnitude of B multiplied by the sine of theta. Now we could go back to our expression for the cross product and our expression for the vector A and our expression for the vector B. We could find the angle theta between A and B. We could find the cosine of that angle easily. Do the square root of 1 minus the cosine squared, we would have the value of the sine. We could multiply the square root of ax squared plus bx plus ay squared plus az squared, which is the magnitude of A. Square root of bx squared plus by squared plus bz squared is the magnitude of B. And then we could show that that's equal to the magnitude of A cross B, which would be a pretty messy, the square root of AY BZ minus AZ BY quantity squared, etc. Here. And we could simplify that and show that we have an identity. So it wouldn't be overly difficult, but it'd be really messy. You'd have to do your bookkeeping, take a couple of pages to write it out. And we don't need to go into that detail. Simply say that from our definition, we can conclude this. And this is an extremely useful and powerful correlation. I'll comment that the definition of the cross product could have been taken as this. The cross product is perpendicular to both vectors, and it has magnitude given by this formula. If that's the case, then it turns out that the cross product has to have the properties that I cross j equals k, I cross k equals negative j, and j cross k equals I cross I is 0, j cross j is 0, etc. Just the definition that I used, okay? It was completely equivalent. This could be your definition, and we could conclude that. That could be your definition, and we've pretty much concluded this. The definition could be just the determinant formula. We could take the determinant definition as our definition. We could take this formula as our definition. This is equivalent to this in a way that's really easy to see, is equivalent to our original definition as we showed, is equivalent to this. And it's at least somewhat important to understand that. Not that you're not going to believe me if I just give you this definition or this definition, okay, or the definition I gave, or this as the definition. But one follows from the other, and you get a deeper insight in understanding to some extent how those definitions are connected.